Hi, Rajan this. Welcome to the channel. So we have started 100 question DSA series to crack any coding interview, and today we are going to discuss fourth problem, which is count subarray with given XOR. Now in this problem, you will be given an array of integers that consist of n numbers and one extra integer k, and your task is to find how many subarrays are there such that the XOR of all the elements in the subarray is equals to k. For example, in this test case 42264, and we have to find out how many subarrays are there such that the XOR is equal to 6. So there are 4 subarrays which we can see. The first subarray is 4 and 2, that consists of just 4 and 2. So the XOR of 4 and 2 is equal to 6. We know. We can also look at the binary representation of 4. So the binary representation of 4 is 0, 1, 0, 0. The binary representation of 2 is 0, 1 and 0, right? So if you take a XOR value here, so 0 XOR 0, 0, 0 XOR 1, 1, 1 XOR 0, 1, so which is equals to 6. So the XOR of 4 and 2 is 6. So this is one possibility that consists of 4 and 2, right? Now if you look at this subarray that consists of 2, 2 and 6, the XOR here is also 6 because the XOR of 2 same number is equal to 0, right? So 2, 2 and 6 is second subarray. Now if you look at the third subarray that consists of just a single element 6. So here, since there is just one element, for the XOR is equals to that number itself, and which is 6. Now if you look at the whole complete array that consists of 4, 2, 2, 6 and 4, right? So if you take the XOR of 4 and 4 is 0, the XOR of 2 and 2 is 0, so what you left with just 6. So the XOR is equal to 6. So there are 4 subarray which we can clearly see, and the XOR of all the numbers in individual subarray is equals to 6, right? So let's see how to start with. So we will start with the brute force first. So the brute force approach could be to go through each possible subarray and take a XOR, and if that XOR equals to k, just increment your answer, right? So just a pseudo code of it would be, let's say I started with an answer, right? So let's say this is my answer. I will start with 0, right? So I'll take help of 2 for loops. So one would be from index 0 to n minus 1. This is the left index. Now I'll take another for loop for the right index, that would be from index I plus 1 to n minus 1, right? So in this this subarray consists of all the numbers from index I till j, right? So I plus 1 and so on, right? So then now to find out the XOR of all the numbers in that range, we can have another for loop. So we will take all the numbers from index I to j, right? So let's say that number is x. So we will just check what is my current XOR. So I will take XOR equals to x, and then for once this for loop finishes, we will just check if that XOR value is equals to k, increment my answer plus plus, right? So the complexity for this approach is order of n cube, which is too much. We will try to reduce this complexity. We will try to solve this problem in order of n square first. So and then we will try to convert again into order of n, right? So this is the order of n cube solution. You start with your left index and try to go with all possibility of right index. So it means that we are going through each possible subarray, and in each possible subarray we will try to find out what is the XOR value of all the numbers. So this third for loop is used for calculation of all the the XOR value of all the numbers in that range from index I to j, right? We will try to reduce this part. So to convert order of n cube to order of n square, you must remove at least one of the for loop, right? So we will try to remove this for loop. Let's see how. So in this approach, in this order of n cube approach, if you observe it here, like the job was third loop was to calculate the XOR value of all the numbers from index I to j, right? Let's see how we can smartly do it. So our objective is to find what is the XOR value of from index I to j, right? And what is the XOR value of I to j? This is nothing but, let's say your given array is, let's say this is your given array that consists of number x0, x1, x2 and xn minus 1, right? So what is the XOR value of I to j? This is nothing but xi XOR xi plus 1, so on, and with XOR of xj, right? Now in order to calculate the XOR value of all the numbers from I to j, we will take help of the prefix XOR. So prefix XOR means that, let's say I have p0. The prefix XOR at index 0 means just that number itself, single number. P1 would be x0 XOR x1, P2 would be x0 XOR x1 XOR x2, and similarly P3 would be x0 XOR x1 XOR x2 XOR x3. So what essentially this prefix stores, this prefix pi store the XOR value of all the numbers from index 0 to I, right? So we will take help of this prefix XOR in order to calculate this value. Let's see how. Let's say what is your pj? Your pj would be the prefix XOR of all the numbers from index 0 to j, right? Which is nothing but x0 XOR x1, xi minus 1, this is XOR, then XOR xi, and similarly xj, right? Now what would be your pi minus 1, which is nothing but x0, I mean the XOR value of all the numbers from index 0 to I minus 1, right? So if you take a XOR value, right, you would see something magic here. The XOR, we know that the XOR of two same number is 0. So here 0, 0, 0 till index 0 I minus 1, this is 0, and what you left with this number xi, xi plus 1 and xj. So what it means, the XOR value of all the numbers from index I to j, which is nothing but pj XOR pi minus 1. So now if you remember, in our brute force approach, the order of n cube approach, the third for loop was to find out the XOR value of all the numbers from index I to j, right? So instead of using a loop, we will be making use of this prefix XOR information. So now we know that the XOR value of all the numbers from index I to j is nothing but pj XOR pi minus 1. So we can make use of it. So now our complexity reduced to order of n square, right, from order of n cube. So n square, because we are still going through each possible subarrays. So let's say this is a subarray from index I to j. Now to calculate the XOR value of all the numbers in this range, we can take help of the prefix XOR. So that will tell you what is the XOR value from index I to j in order of 1, right? So the complexity is still order of n cube. And now we will try to reduce this complexity from order of n cube to order of n. Let's see how. By now we have already discussed order of n cube solution, order of n square solution. Now we will look at order of n solution. So we know that in this problem we have to find out how many subarrays are there such that the XOR of all the elements in that subarray is equals to k, right? And any subarray always ends at somewhere, right? So here from index I to j, this subarray ends at index j. So now in this optimized approach, what we will do, we will go through each possible end index. So let's say that index is j equals to 0, j less than n minus 1, sorry, j is less than n, j plus plus, right? So this is my right index, this j. Now for this corresponding j, this is my j, I will try to find how many i's are there, such that the XOR value is equals to k. What it means? It means that let's say there is a subarray that ends at index j, right? All right. Now we will try to find how many i's are there, how many I1, I2, I3 are there, such that the XOR value is equals to k. So and now we can make use of this formula. We know that the XOR value from index I to j is nothing but pj XOR pi minus 1, right? So let's say this is index I, this is index I minus 1. So what is k? K is nothing but the XOR value from all the numbers from index I to j must be equals to k. So can we write k equals to pj XOR pi minus 1, right? So if you take if you do XOR with pj on both side, you would get pi minus 1 is equals to pj XOR k, right? So from here we can clearly see, in order to find how many subarrays are there that ends at index j and whose XOR is equal to k is nothing but count how many previous prefixes are there such that their value is equals to pj or k. So here the idea is count count how many previous prefix XORs are there whose value is pj XOR k. So yeah, I hope you understand. For each index say we will try to find how many prefix XORs are there such that its value is pj or k, and we can simply, what we can do, you can simply answer plus equals to the count of this. Now in order to store this count, right, we can make use of a hash map. So we will use a hash map that essentially stores the frequency of each prefix XORs. So answer is equal to mp of this pj XOR k, right? And that's it. So here we are just using one loop and we are fetching the information from this hash map. We can simply use unordered map here, to get uh, the frequency of pj's or k in order of 1, right? So the overall complexity for this approach is order of n, and we have successfully achieved that from order of n cube to order of n square and then again to order of n, right? I hope you understand this approach. If you have any difficulty or doubt anywhere, please try to comment. I'll reply to each one of them, right? So yeah, let's look at the code now. We'll look at the code. We are given array and integer k. So first find the size of this array. Then we will build the prefix XOR of all these n indexes. And so prefix XOR of 0 is nothing but just a single element array of 0. Now from index I is equal to 1 onward, we will try to find what is my prefix XOR of I. So prefix XOR of I is nothing but the XOR of all the numbers from index 0 to I, right? Means ARR of 0, XOR ARR of 1, XOR ARR of 2, up till XOR with ARR of I, right? So XOR of all the numbers from index 0 to I. If you observe it carefully, what is this? This is nothing but prefix XOR of I minus 1, like the XOR of all the number from index 0 to I minus 1. That's what exactly I have done here. So now my prefix XOR of I is nothing but prefix XOR of I minus 1 XOR ARR of I. So see, prefix XOR of I is nothing but prefix XOR of I minus 1 XOR ARR of I. So till here you have built the prefix XOR. Now the job is easy. Please check out the explanation part. I have explained there why I am using hash map here, unordered map. So for the empty subarray, your hash map of 0 is going to be 1. Now this is my answer, which essentially tells you how many subarrays are there such that the XOR is equals to k. So initially it would be 0. Now go through each possible right index. So for each right index j, what I'm doing here, I'm trying to find how many the count of how many prefix XORs that has value equals to prefix XOR of j XOR k, right? I've explained in the explanation part how this is coming. So here essentially what I'm doing here, for each right index j, I'm trying to find how many left index I which we can find such that the XOR is equals to k, right? And in the explanation I have like derived how this formula is coming, like how we can make use of prefix XOR of j XOR k. So your answer is nothing but hash map of your prefix XOR of j XOR k, and at the end just increment your current prefix XOR, right? So hash map essentially stores the frequency of each prefix XOR, right? So we have to increment the frequency for current prefix XOR, right? And at the end just return the count, like how many subarrays are there whose XOR is equals to k. I hope you understand this part. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.